Every known item in this universe has a mass. But what about those items which are so tiny that even a milligram will be a big unit to measure them? Any idea what I am talking about? Well, here we are going to discuss the tiniest but most significant part of chemical compounds and even matter, which is an atom. And what unit of mass can be used to measure such a tiny atom? Well, this brings us to the concept of atomic mass. The atomic mass of an atom is an extremely small number because the atom itself is tiny. In the 19th century, there was no device or equipment to measure atomic mass. So the scientists determined the mass of one atom relative to another. At that time, hydrogen was the lightest element and was assigned the atomic mass of 1. Without any unit, all other elements were assigned mass relative to it. However, from the year 1961 onwards, carbon-12 was considered the standard. It is one of the isotopes of carbon and is denoted as 12C. The atomic mass of carbon-12 is 12 atomic mass unit or AMU, and the masses of all other atoms are given relative to it. 1 atomic mass unit equals 1/12 of the mass of carbon atom, and 1 atomic mass unit is equal to 1.66056 into 10 raised to minus 24 gram. Let us calculate the mass of hydrogen in terms of atomic mass unit. We already know that the value of 1 atomic mass unit is 1.66056 into 10 raised to minus 24 gram. The mass of 1 atom of hydrogen is 1.6736 into 10 raised to minus 24 gram. So, to calculate the mass of a hydrogen atom in terms of atomic mass unit, we will divide the mass of 1 atom of hydrogen by the value of 1 atomic mass unit. The answer we get is 1.0078 atomic mass unit. One important point here is that nowadays atomic mass unit or AMU is replaced by U, which stands for unified mass. So now we are coming to a concept that is quite similar to an atomic mass. It is known as average atomic mass. In practical calculations, whenever we use the atomic mass of an element, it is always the average atomic mass of an element. The reason behind this is that every naturally occurring element has more than one isotope. When we consider the existence of all the isotopes and their relative abundance, that is, their percentage occurrence, we can get the average atomic mass by multiplying the atomic mass of isotope and their relative abundance. For example, carbon has 3 isotopes and their relative abundance and atomic mass are given here. So, the average atomic mass of carbon is 0.98892 into 12 unit plus 0.01108 into 13.00335 unit plus 2 into 10 raised to minus 10 into 14.00317 unit, which is equal to 12.011 U. Similarly, we can calculate an atomic mass for other elements also. In fact, the atomic mass of the elements of the periodic table is actually their average atomic mass. Let us now discuss the concept of molecular mass. So the name itself says molecular mass means the mass of all the elements constituting the molecule. It is obtained by multiplying the atomic mass of each element by the number of its atoms and then adding them together. For example, let us calculate the molecular mass of methane, that is CH4. If you look at the structure of methane here, you can see that there are 1 carbon atom and 4 hydrogen atoms attached to that carbon. Each carbon atom has 12 unit mass and hydrogen has 1 unit mass. Therefore, molecular mass is obtained by adding the atomic mass of carbon with the multiplication of the number of atoms of hydrogen with the atomic mass of hydrogen. Thus, the molecular mass of methane is obtained as 16.043 U. Our last concept of this video is the formula mass. So, formula mass is calculated for ionic compounds which have ions as their constituent units rather than discrete molecules. Let us take the example of NaCl, that is sodium chloride, our ordinary table salt. It has 1 positive sodium ion surrounded by 6 negative chloride ions and vice versa in a 3-dimensional structure. Thus, the formula mass of sodium chloride is the atomic mass of sodium plus atomic mass of chlorine, which is equal to 23 plus 35.5, which is equal to 58.5 U. Now at the end, I would like to pose a question for you. We all know that 12 bananas means 1 dozen, 6 means half a dozen. Have you ever thought if we take atoms and molecules together in a substance, what unit can be used to describe their huge number in a substance? Think about it, as this will be the topic of next video. With this, I will summarize this video.
Manorama Horizon. Learning made simple.